All right, moving on down our tree to the left. After setting our boundary conditions, we come to two tabs that let you define how the simulation is obtained and what to do with it. So the first one is numerics, which is basically just about, like when this thing goes to do the simulation, what solver should it use? If you know anything about like how finite element method works, basically you're creating a system of linear algebra equations for it to solve. So in this case, since we're doing a linear solution, like we didn't turn on the nonlinear solver, or the nonlinear heat transfer simulation, it's going to use just a ax equal b kind of like linear algebra solver. The default is what's called mumps, which is basically just like a direct like solver, kind of like doing Gauss elimination. It's fine. So it's designed to be like parallelizable. So the mumps solver is the default. Don't change it unless you know what you're doing. If you have a particularly large problem and it like seems like you're not getting solutions fast enough, the one at the bottom named PETSC, so that's the PETSC solver, is an iterative solver, which is designed to like reduce memory requirements and go a lot faster for big problems. So I would say if you have like more than about 2 million elements in your system or 2 million unknowns, you might consider using the PETSC solver instead of the mumps solver. I've never personally used some of these other solvers. It says that the multi-frontal one behaves well, but I don't know if it's actually faster. So your mileage may vary, but basically the mumps solver is pretty good for smaller problems. Very fast. I wouldn't mess around with any of these other settings unless you know what you're doing. If you go to do the nonlinear solution, you'll be given a couple more options that have to do with like how many refinements of that iterative, because that involves both a direct solver and an iterative method at the same time. So in that one, you'll be given a couple more options, but generally the defaults here are pretty good. Simulation control, haha, surprise, there's nothing in here. In the simulation control, I think there's a lot more control when you do the transient simulations, but for the steady state ones, it basically just asks you like how many processors do you want to use, which usually you want to leave it set to automatic. But if you're really trying to like reduce how much wall time, so like how long you on a computer physically need to wait, you can use more cores. Generally that'll use more core hours because each core will operate less efficiently. And the maximum runtime is how much physical like time like you as a user sit there waiting for the thing to run. Now keep in mind that if it's using, so what is it, 3600 seconds is 1 hour of physical time. If you're using 64 cores, then that means you could use up to 64 core hours while doing that simulation. It doesn't mean it's actually going to take that long. That's just like the cap. Like don't use more than that amount of time, or it'll automatically terminate. So this just protects you from using too many of your CPU hours on a simulation that's never going to converge anyway. Just leave it set at the default if you don't know what you're doing. All right, that's all we need to talk about for the numerics and simulation control for now.